Okay, here's a couple more questions on tangent and chord properties, so pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for question 1, part A, we need to find the equation of the circle, and we're given the centre of the circle, so therefore we know the equation is going to be x minus 2 squared plus y minus 1 squared is equal to r squared. So how do we find the radius? Well, we're given a point on the circumference and we know the centre. So therefore, the distance between these 2 points is going to be the radius. So we can use a distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared, and all of this is square rooted, and if we sub the values in we can get the radius. So the radius is going to be the square root of 10 minus 2 squared plus 7 minus 1 squared, and if you put that into calculator it will give you out 10, which is the radius. So therefore we can write the equation of the circle as x minus 2 squared plus y minus 1 squared is equal to the radius squared, which we figured out as 10, so it's going to be equal to 100. So for part B, we need to find the equation of a tangent at the point B. So as I said before, the way I approach these questions is I always draw a diagram to help me answer the question. So we know the centre, which is actually called the point A. We know the centre, which is equal to 2, 1. And we know point B, which we'll say is somewhere up here. Point B is equal to 10, 7, and there is a tangent at point B. There's a tangent at point B here, and let's draw in the radius here, and remember that they are perpendicular to each other like this. So this is the diagram of what we're working with, and we need to find the equation of L1, which is this line here. So how can we approach this? Well, we can find the gradient. Remember how we did it before? We can find the gradient of the radius because we have 2 points on the radius, the centre and the point B, which is also on the radius. So we can say that the gradient of the radius is going to be 7 minus 1 over 10 minus 2, which if you put into a calculator is equal to 3 over 4. And therefore we can find the gradient of the tangent is going to be equal to, because the radius and the tangent are perpendicular, the gradient of the tangent is going to be the negative reciprocal of the radius. So the gradient of the tangent is going to be minus 4 over 3. We flip the fraction. So this is the gradient of the tangent. Now we need to know a point on the tangent, and then we can use the equation y minus y1 is equal to m x minus x1. And we do know a point on the tangent because we know the tangent is at the point B, which is 10, 7. So therefore we can write the equation of the tangent as y, using this point here, y minus 7 is equal to minus 4 over 3, as we're using the gradient up here, 4 over 3 x minus 10. And this is actually a perfectly acceptable final answer. You don't need to put it in the form ax plus by plus c is equal to 0, because there is no point in the question in which it actually says that you need to do that. So if you leave it in this form, this is an acceptable answer. Okay, so for part C, it refers to L2, and it says that L2 is parallel to L1, and it passes through the midpoint of AB. So if we put that midpoint of AB being about here, and it's parallel to L1, we can draw the line looking something like this here, where this is L2. And it says that L2 intersects C at the points P and Q. So P and Q are going to be these points here where the line intersects the circle. And we need to find the length of PQ. So if I do this in different colours to make it a bit more clear, the length of PQ is going to be connecting P and Q. So we need to find the length of this line here. So as we need to find the point of intersection between L2 and the circle, what I would do is find the equation of L2. So as L2 is parallel to L1, it's going to have the same gradient. So the gradient of L2 is going to be the gradient of L1. This little L2 is just indicating I'm talking about L2. It's going to be the gradient of L1, which we figured out as the tangent as minus 4 over 3. So the gradient of L2 is also going to be minus 4 over 3. And we can use the equation y minus y1 is equal to mx minus x1 because we have a point on L2 because it says L2 passes through the midpoint of AB. So the midpoint of AB, I'm just going to do it in my head, but you could use a formula if you want to. We need to find the midpoint of the x coordinates 10 and 2, and that's going to be 6. And we need to find the midpoints of the y coordinates 1 and 7, and that's going to be 4. So we can sub this, the midpoint, as one of the points on L2. We can sub this into the formula, and we can do y minus 4 is equal to m, which is minus 4 over 3, x minus 6. Now we need to sub this into the equation of the circle. So to do this, I'm going to make y the subject. So first of all, I'm going to expand the brackets to do y minus 4 is equal to minus 4 over 3 x plus 8. And then I'm going to move the minus 4 onto the other side to do y is equal to minus 4 over 3 x plus 12. So I just ran out of some space there, so I had to clear some stuff. So now we sub this into the equation of the circle in order to get the point of intersection. So we do x minus 2 squared plus, and we do the y value, which is minus 4 over 3x plus 12 minus 1, which will be equal to plus 11 squared is equal to 100. Then we can expand the brackets, do x squared minus 4x plus 4 plus 16 over 9 x squared minus 88 over 3x. If you need to expand this and do it slowly, that's fine. But remember, you just times this number by this number, then times it by 2 in order to get the minus 88 over 3. Plus 121 is equal to 100. Then we can simplify this to do 25 over 9 x squared minus 100 over 3x plus 125 is equal to 100, and then we can bring the 100 on the other side to do 25 over 9x squared minus 100 over 3x plus 25 is equal to 0. And then we can put this into the calculator in order to find what the values are. And if we do this, we get the x values as 6 plus or minus 3 root 3. And then we can find the y values by subbing this in. So we sub it back into this up here. So we do y is equal to minus 4 over 3 6 plus 3 root 3 plus 12, which is going to be equal to 4 minus 4 root 3. So one of the coordinates is 6 plus 3 root 3, 4 minus 4 root 3. And the other coordinate is going to be y is equal to minus 4 root 3, 6 minus 3 root 3 plus 12, which if you put that into a calculator is equal to 4 plus 4 root 3. So the other coordinate is 6 minus 3 root 3, 4 plus 4 root 3. Okay, so now we have the points P and Q. We can find the distance PQ by using the distance formula, which is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and all of that square rooted. So we can do this. This is quite a long one, so be careful with this. It's D is equal to 6 plus 3 root 3 minus bracket 6 minus 3 root 3 bracket and then the bracket squared plus 4 minus 4 root 3 minus bracket 4 plus 4 root 3 bracket and then the bracket squared, and then all of that square rooted. And if you put that into a calculator, you will get out the value of 10 root 3, and that is the length of PQ. the way I record these videos is I find a question that I like from a past paper, and all I do is I just get the answer, and I work through the question in the video in the real time as you're seeing it. And as I was doing question C, and the more I went through it, the more I realised that this was quite a long method in order to get 3 marks. The way it involved surds and quite complicated surds as well. I think that was more maybe like a 5 mark or possibly even a 6 mark question. I wouldn't have associated it with a 3 mark question. So I looked at the actual mark scheme. The reason they've given it 3 marks is they actually do it a different way. And I actually think it's quite interesting the way that they do it. And I wanted to talk about it quickly. Because I think if any of you did it this way, first of all, fair play, because I didn't see this until I looked at the method. But if you draw a line here and a line here, and I'm just going to expand this little triangle over here, it's going to look like this triangle here. Here. Now, these lines here that we just drew in are actually the radius of the circle. So we actually know the length of these. The length of these, as we figured out before, is just 10. And the length of this line here, this, remember, is the midpoint here. This is the midpoint of A and B. So this is going to be half of the radius that we made earlier. So this is going to be 5. And these two angles here are going to be right angles because, I mean, you can pretty much see this, but basically the reason is because this is actually the perpendicular bisector of this chord here, PQ. It's actually the perpendicular bisector of PQ because it's going to be perpendicular because this radius and this tangent are perpendicular, and the line L2 has the same gradient, remember, and it passes through the midpoint of AB, which is the midpoint of PQ. So therefore, it's going to be the perpendicular bisector. So therefore, it's going to be perpendicular here. And as you can see, we've actually created 2 identical, congruent right angle triangles. So what we can actually do is we can actually find the length of both these sides easily by using Pythagoras. What we can do is, this is the hypotenuse, we can do 10 squared minus 5 squared and square root this, and this will give us, if you put it into a calculator, is equal to 5 root 3, and this is the length of this side, and then you can just find the length of this side as well, so you just times it by 2 because they're the same, and you're going to get 10 root 3, and this is the line PQ, and this is actually the answer. And this is actually a lot quicker way of doing it. So I was quite surprised when I saw this, and if any of you did this, then again, well done, because I didn't see it this way. But the thing to take away from this is how powerful diagrams are. Maybe if I drew the diagram a bit bigger, I have to draw it quite small because I'm on a drawing tablet, but maybe if I drew the diagram a bit bigger, I would have actually maybe seen this, I'm not sure. But the thing is that this is why diagrams are so important, because that is the only way that you would have seen that method and you would have saved a bit of time. It's not the end of the world if you didn't spot that method. As I said, I went through the method beforehand that got us to the right answer, and it's not loads and loads of time saving, but it's a significant amount. But it is quite an interesting method, and I thought I would include it in the video. Okay, so for question 2, part A, this one actually took me quite a while in order to figure out what to do, so don't panic if you didn't get it straight away either. My first thought was to use the point T in some way in order to make simultaneous equations using 2 distance formulas, but it doesn't actually give you the value of point T, so I wasn't really sure what to do. However, I did realise in a sec, it's similar to the method from before, in the fact that you've got to add a side here in order to make a triangle. And then this is going to be a right angle, remember, because the tangent and the radius are 90 degrees, they're perpendicular to each other. So therefore you've got a right angle triangle here, and you know the 2 sides. So therefore you can figure out this side here by doing Pythagoras, which will be the square root of 6 root 5 squared plus 4 squared, which if you put that into your calculator is equal to to 14. So this side here is 14. But why is this useful to us? Well, because we know the coordinates of Q, which is 11, K, and obviously we know the coordinates of this point here because this is just 0, 0. So therefore you can set up a distance equation. Remember, distance is equal to, between 2 points, is x2 minus x1 squared plus y2 minus y1 squared. You can set up a distance formula between these 2 points, and you can say that it is the square root of 11 minus 0, so it's just going to be 11 squared plus k minus 0, which is just k squared, and all of this is going to be equal to the distance between the 2 points, which we know now is just equal to 14. We can simplify this and do the square root of 11 squared, which is 121, plus k squared is equal to 14. We can square both sides to do 121 plus k squared is equal to 196, and then we can do k squared is then equal to 75, and then we can square root both sides and say that k is equal to the square root of 75, which is plus or minus 5 root 3. However, it says that k is a positive constant, so therefore we know that k cannot be a negative number, so it cannot be minus 5 root 3, so therefore k is equal just to 5 root 3. So for part B, this is just find the equation of the circle, and this is quite easy, because we now know the centre of the circle, which is going to be 11k, which we now know is 5 root 3. Remember that the centre of the circle is Q, and we now know that Q is 11 5 root 3. And the radius is going to be equal to 4, because we have this line here, remember, and this is the radius between the centre and a point on the circumference. It doesn't matter if we don't know what t is. We don't know what t is, but it doesn't matter, because as long as you know the radius, it doesn't matter at all. So we know the radius, so therefore we can write the equation of the circle as x minus 11 squared plus y minus 5 root 3 squared is equal to 4 squared, which is equal to 16. And this is the final answer.